To start off Chapter 8, we're going to talk about inverse variation. As an equation, direct variation would represent y equals k times x. So your x value or your input is being multiplied by a constant k value to give you your output of y. That would be direct variation. Inverse variation would be y equals k over x. So when two quantities vary inversely, as one quantity increases, the other one decreases proportionally. So that's what that inverse variation equation represents. And for both of these, it's important that we have a constant of variation, which we call k. And to start here, let's just look at identifying direct and inverse variations. Is the relationship between the variables here direct, inverse, or neither? So here I see that as my x values are going up, so I go from 2, 4, 10 to 15, my y values are going down. So in the back of my head, I'm probably going to start thinking this would be inverse variation if anything. How I would check this is to look for a constant k of variation. And I do that by seeing if my x and y values multiplied together give me my k value. 2 times 15 gives me 30. 4 times 7.5 also gives me 30. I get 30 again, and I get 30 again. So my constant k value here is 30, and I know that these vary inversely. So x times y equals 30, and if I wanted to rewrite that in that inverse equation, I would have y equals 30 over x. That would be my inverse variation equation. Let's look at another example. So here we have x and y values. I go from 2, 4, 10 to 15, and then I go 10, 8, 3, 1.5. Again, I'm seeing, okay, my x values are going up, my y values are going down. This could possibly be inverse variation. So let me check to see if I have that constant k value, then I would know for sure. So 2 times 10 gives me 20. Already see here, that's not matching up. This isn't matching up. None of my values match up. So my x times y values are not some constant value of k, so I don't have a consistent proportion here. So there's no inverse or direct variation here. Now, let's look at determining inverse variation. Suppose x and y vary inversely and x equals 4 when y equals 12. What function models inverse variation? So I have my x and y value. All that I really need, though, for an inverse or direct variation equation is that constant k value. So I'm going to use the x and y that are given to find my k value here. So I know that they vary inversely, so I'm going to use this equation. I'm going to find k, so I'm going to plug in 12 and 4 for x and y. All I have to do here is solve for k, so I'm going to multiply 4 on both sides. 48 equals k. So my equation here for inverse variation, or the function that would model it, would be y equals 48 over x. Now let's use that equation to find y when x equals 10. So I use that equation, y equals 48 over x. I just plug in 10. My answer would be 4.8. Now finally, let's look at using combined variation. So let's look at a word problem where this could be helpful. The number of bags of grass seed N needed to reseed a yard varies directly with the area to be seeded and inversely with the weight of the bag seed. So I got a couple different variables going on here. If it takes 2 3-pound bags to seed an area of 3,600 feet, how many 3-pound bags will seed 9,000 feet? So what I'm going to do here first is set up an equation using the variables. So I'm trying to find the number of bags N, and I'm going to write the equation Ka over W. So I have my constant variation value of K. I have that A on top because N varies directly with A. I have that W in a denominator because in the problem it says that N varies inversely with W. So now I have my variables, I have a general equation set up, but I still need to find that K value. So similar to that last problem that we did, I'm going to plug in values for N, A, and W to solve for K here to start. It takes 2 3-pound bags to seed an area of 3,600 feet. That basically tells us all our information here. So 2 is the number of bags. I want to seed an area of 3,600 feet. That's my A value. And the bags weigh 3 pounds, so that would be where my W would go. Now all I have to do is solve for K here to start. Multiply both sides by 3. Divide by 3,600. That simplified 6 over 3,600 would be 1 over 600. So that is my constant value K. So now I can kind of use that in a combined variation equation. I'm going to do N equals A over 600 W. And again, that's just doing N equals Ka over W. I'm just plugging in 1 over 600 for K. Now I'm going to use this equation to find out how many 3-pound bags it's going to take to seed an area of 9,000 feet. So I want to seed an area of 9,000 feet, so I'm going to plug that in for A. I'm still using 3-pound bags, so I'm going to use 3 here. All I have to do is plug that into my calculator, and I get 5. So using all that information, I could determine that it would take 5 3-pound bags to seed an area of 9,000 feet.